we now want to introduce the topic of velocity, and velocity has almost exactly the same type of interpretation that speed does, except that we now have to include direction. And that is included with the fact that our displacement is also a vector, okay? So our average velocity is just defined as not distance over time, but displacement over time. So what is my change in position over some given time interval? And that is just the difference between my final and initial positions over, again, that same time interval. And that is the average velocity. If I know what my total displacement is over some finite length of time, then I can calculate what the average velocity is of my object. The instantaneous velocity, on the other hand, again, considers motion when my time intervals are extremely small or infinitesimally small. And we define the instantaneous velocity mathematically as in the limit that my time interval goes to 0 of delta x over delta t. And this is technically a vector, all right? Those are both technically vector quantities. But as I take smaller and smaller time intervals, okay, this moves more and more closely to the derivative of my function. So if I know what the position of my object is as a function of time, then I can calculate its instantaneous velocity at any given time using the derivative.